Welcome to the first part of the BRINDA tutorial. In this video, I will briefly introduce the background of the BRINDA project and the BRINDA regression approach. So, what is BRINDA? BRINDA stands for Biomarkers Reflecting Inflammation and Nutritional Determinants of Anemia, which is a multi-agency and multi-country working group formed in 2012 in an effort to improve micronutrient assessment and anemia characterization globally. BRINDA's overall goal is to refine approaches to estimate the prevalence of nutritional status, and thus to improve the targeting, design, and effectiveness of nutrition research and programs. We pull data from national and subnational nutrition surveys to examine the relationship between inflammation and nutritional biomarkers, and to identify factors associated with anemia in highly prevalent groups. Now, what's the matter here? As you may know, some nutrient biomarkers are affected by inflammation, which can lead to incorrect diagnosis of individuals and to overestimation or underestimation of the prevalence of deficiency in a population. In BRINDA, we use CRP or AGP to reflect individuals' inflammation status, and the nutrient biomarkers that we are interested in include ferritin, zinc, vitamin B12, retinol, etc. In this tutorial, ferritin was taken as an example of nutrient biomarker, and we will use both CRP and AGP as the biomarkers for inflammation, since they reflect different stages of inflammation. Specifically, CRP rises to a maximum between 24 and 48 hours, while AGP may take 3 to 5 days to reach a plateau. Let's take a closer look at our example. When a person has inflammation, CRP and AGP will increase. Since ferritin is an acute phase protein as well, it will also increase. Now, if you want to use ferritin to reflect a person's iron status, you should take inflammation into consideration. Otherwise, it may cause problems with the interpretability. The second problem of ignoring inflammation is over or underestimation of the prevalence of deficiency in populations. Let's see a hypothetical example of ferritin concentrations in populations with or without inflammation. A population experiencing inflammation will exhibit increased ferritin concentrations, shown by the rightward shift of the distribution of log ferritin. In such a scenario, the area shaded with solid lines represents the portion of the population misclassified as having sufficient iron stores while experiencing inflammation. These individuals would be correctly identified as having insufficient iron stores and fall in the dashed line shaded area if ferritin samples were taken when the population was not experiencing inflammation. There are many ways to address these issues. The BRINDA regression approach is one of them. The BRINDA regression approach uses linear regression to adjust ferritin concentrations by CRP and/or AGP concentrations. Briefly, the adjusted ferritin concentration is calculated by subtracting the influence of CRP or AGP, or both. We need a CRP or AGP reference value because we don't want to over-adjust ferritin for low levels of inflammation. Let's take a look at this scatter plot of ferritin by AGP, both on log scale. These data were from Kenya 2010 survey of preschool children. The blue dots were those who had sufficient ferritin, while the red dots were those who had insufficient ferritin. The scatter plot generally shows a linear relationship between AGP and ferritin. The big red dot is a hypothetical child in Kenya who has elevated AGP and a ferritin above the cutoff, so this child would be classified as not being iron deficient. What would his or her iron status be if inflammation was removed? Following the blue line to the orange dot, you would get a data point of 0 AGP, but there are no 0 values for AGP in this dataset, so correcting to 0 would be too much, i.e. overcorrection. Instead, we want to correct to a relatively low level of AGP, which is the green dot, or the AGP first decile in this tutorial. Then how can we obtain the actual CRP and AGP reference values? Here we use the maximum values of the lowest decile that were calculated from BRINDA 1 datasets. For example, for CRP, we recalculated the first decile cutoff in R and got negative 2.26 for log CRP reference, and negative 0.52 for log AGP reference. Next, let's talk about how to obtain the coefficients for log CRP and log AGP. First, we natural log transform our outcome variable, i.e. ferritin, and our explanatory variables, i.e. CRP and AGP, to meet the assumptions of linear regression. Then, we use survey data model the effects of CRP and AGP on ferritin using a simple linear regression. The BRINDA team has developed a macro to make this very easy, and I will walk you through an example of how to use this macro in the second part of the tutorial. This step will give you the estimates for the regression coefficients, i.e. the betas. By then, we have obtained all the estimates for the parameters and can calculate the adjusted ferritin concentrations by inserting the unadjusted ferritin value, the observed CRP value, and the observed AGP value. Finally, let's briefly talk about when should we apply the BRINDA regression approach. When deciding if there is a rationale to apply this approach, we first ask two basic questions. Is there a clear biological rationale for the relationship between the nutrient biomarker and inflammation? If the answer is no, then clearly the BRINDA regression approach is not needed. If the answer is yes, or even if we don't know, the next step is to look at the data and see if there is a meaningful association between the nutrient biomarker and inflammation biomarkers. If a meaningful association does exist, then the approach may be recommended. If a meaningful association does not exist, then again there's no need to apply the BRINDA regression approach. To date, the BRINDA regression approach has been applied to ferritin. It has also been applied to serum retinol and retinol binding protein, two biomarker indicators for determining vitamin A deficiency. Currently, we do not recommend adjusting vitamin B12, serum folate, and zinc. Thank you for watching the tutorial. If you have any question or need more information, please feel free to visit our website.